All right, tonight, as promised, I'll put another video out. Tonight I'm going to work through some problems and measures of variation. So along these slides, it'll not be a long video, but along these slides I've got some number sets, some very small number sets just to work with, a reiteration of what I've talked about before in terms of range and deviation, standard deviation and variation. Sorry, I'm just messing with my sound effects. So let's go ahead and get started. I'm going to work through some of these problems and I'll post the video tonight. And I'm going to also make an assignment, as I've talked about, from the book that I've uploaded into Canvas. So without further ado. All right. So the range is just basically you take a look at a set, you find the highest number, you find the lowest number. That's the range of the numbers in between those two. So you take the highest number and subtract the lowest. In the case of this set right here, it still sounds like my music is a little bit too high. Turn it down, because that's supposed to be very low in the background. I apologize for that. Okay, so as I'm looking at this, whoops, I want to find the highest number. As I go left to right, it looks like 12 is my highest number. So my range is going to be the maximum data entry subtract the minimum data entry. So if 12 is my highest number, I'll just underline one of them. What is my lowest? Looks like 5. I don't like that. So my range equals 12 subtract 5 equals 7. So there's my range of this particular data set. Now range tells us a little bit about it, but I could have a bunch of 12s and only one 5, and I could say that the range of the data is 7. From 0 to 12, my range of data in this particular assessment, let's say, is 7. That doesn't tell us a whole lot because I've got a whole bunch of 12s packed up at one end. So your measures of center, your measures of variance are going to outline what this set looks like a little bit better than just the range. But this is a starting point. I'm not trying to dismiss range at all. This is a starting point for us that the range is 7 in this particular set. Okay, very easy. It's our starting point for tonight. All right, deviation. So again, this is a little bit of a review from some of the previous videos and some of the previous stuff I've done on here. Deviation of any entry X in a population data set is the difference between the entry and the mean mu of the data set. So in this particular set, I've got to find the mean first, and then I'm going to find the deviation of any particular entry, or all of these entries, as is going to be seen on the variance. So let's find the mean. So back to measures of center. A little orangey. So let's remember what, and we're working with, if you noticed here, we've got mu. So because we've got mu, I'm going to say that we're working with a population because mu represents the mean of a population. So let's assume this small set is a population. So the mean is going to be the summation of the x values divided by big N. And a lot of times you'll see this denoted by x sub I, which means x sub 1, x sub 2, x sub 3, x sub 4. All these numbers represent a location along this particular line left to right. So x sub 8, x sub 9, x sub 10. So each one of these you'd have x1 plus x2 all the way across. Okay. Let me get rid of that scribble. All right. So this is going to look like 9 plus 5 plus 9 plus 10, 11 plus 12 plus 7 plus 7 plus 8 plus 12. 12, 8, 7, 7, 12, 11, 10, 9, 5, 9. Okay, and all of that is going to be divided by how many here? 1, 2, 3, 5, 6, 7, 8, 9, 10. 10. All that's divided by 10. That'll give me the mean. Well, I haven't necessarily done this particular problem finding the mean, so let me just go. I got 9 plus 5 plus 9 plus 10 plus 11 plus 12 plus 7 plus 7 plus 8 plus 12. Double check. 12, 8, 7, 7, 12. 11, 10, 9, 5, 9. Good. 90. So equals 90 divided by 10 just equals 9. So the mean of this set is 9. So I'm going to write that up here at the top. I'm just going to put that the mean is 9. I'll put it right up there. Then I'll erase all this out. Take a second. And now we're going to look at finding the deviations of this particular set. So what it's going to be is we're going to have 9 minus 9. That's a deviation. We're going to have 5 minus 9. That's a deviation. In other words, you find the x value from the set, and each x value from the set, and you subtract the mean from it. So I've got 5 minus 9. I've got 9 minus 9. 10 minus 9, 11 minus 9, 12 minus 9, still showing up on the screen, yes it is, great, 12 minus 9, 7 minus 9, 7 minus 9, 8 minus 9, whoops, 12 minus 9, and I'll stay consistent with parentheses. 9 minus 9 is 0, 5 minus 9 equals minus 4, 9 minus 9 is 0, 10 minus 9 is 1, 11 minus 9 is 2, 12 minus 9 is 3, 7 minus 9 is minus 2, 7 minus 9 is minus 2, 8 minus 9 is minus 1, 12 minus 9 is 3. Add those up. These are the deviations of this entire set, the deviation of the individual x values from the mean. Okay, I've been stating all along this adds up to 0, so here's case in point on this one slide as I work it out. So I've got minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 0, minus 2, minus 3, 3, 0. So I just kind of added those integers up in my head. And there we go. Okay, so the sum of the deviations equals 0. So, and I'm going to go back to this in just a second, but when we're working with the variance, we are going to be working with the summation of the deviations. However, we're going to square each one of those. So we will square this, square this, square this, square this, square this, all the way down. There we go. And we'll find what's called the sum of squares in this particular piece of the variance. Okay, so enough on the deviations. Let's move on into our next step. And this is supposed to be some problems that I'm doing on variation. So I'm trying to expand a little bit with each one of these short videos. Now I'm going probably a little longer than I should, but I'm trying to give some explanation as we go through. All right, population variance. All right, the variance of a population data set of n entries looks like this, and we've gone over this. And remember, I did state that if you're going to work through problems, my recommendation in a math class, especially when you're getting used to a formula, you derive it, you work with it. As you're working with it, write it every time you do a problem. Get familiar with the breakdown of it every single time. So if I was going to find the population variance, this is the same set as the previous, yeah, same numbers. If I'm going to find the population variance of this population, this is how I'm going to do it. And this is strictly by hand. And in a second, I'll go to the calculator and work through the finding the variance and standard deviation. So I'm going to start by, I'm going to practice what I preach. I'm going to write my formula. So lowercase sigma squared is equal to uppercase sigma x minus, I'll write it as the formula, mu squared divided by n. What was the mean of this thing? Was it 9? Yeah, it was. So, just for reference. So I'm going to write each of these pieces out. And again, just like in my previous, I could probably write all of these out. Let me see if I can. I don't know. Each term is going to look like this. So I'm going to have 9. I'm just going to go left to right, by the way. We read left to right. It's easier to keep up with which ones you've done left to right. And commutative property says it doesn't matter which way we do it, summation is going to come out and be the same. So I'm going to say 9 minus 9 squared divided by 10 plus 5 minus 9 squared divided by 10 plus 9 minus 9 squared. I don't even need to write it, but I'm for illustration because 9 minus 9 is 0. 10 minus 9 squared divided by 10. So I'm at 1, 2, 3, 4. Now I'm at 11. So then I've got plus 11 subtract 9 squared divided by 10 plus 12 minus 9 squared divided by 10 plus 7 minus 9 squared divided by 10 plus 7 minus 9 squared divided by 10 plus 8 minus 9 squared divided by 10 plus 12 minus 9 squared divided by 10. Okay, that's laid out on paper. Normally you'd have it laid out this way, but it's okay that I went underneath. I just wouldn't have any room otherwise. I would go back through these, make sure I had all those, and I do. And let me just, I would only mark them off so I know where I'm at. Undo those. All right. So now I need to find each term and what it is. Well, 9 minus 9 in this first one right here is 0. 0 squared is 0, divided by 10 is 0, so that becomes 0. 5 minus 9 is minus 4. Minus 4 squared is 16, so I've got 16 divided by 10. So here I've got 1.6. This is another 0. 10 minus 9 is 1. Now I've got 1/10, which is very easy. And just get a 0.1. 0.1. 11 minus 9 is... Oh, did I square that? Oh, it didn't matter because it's 1. Duh. So 1 squared is 1 divided by 10, yeah. In this one, 11 minus 9 is 2. 2 squared is 4. So here I've got 4 divided by 10, another very easy one. And we've just got a 0.4. 12 minus 9 is 3. 3 squared is 9. I've got 9/10. That's 0.9. 7 minus 9 is minus 2. That's 4 divided by 10, so I've got another 0.4. 7 minus 9, oh, same thing. 0.4. So the 7 minus 9 squared with the minus 2 is the same as the 11 minus 9 with a 2. 2 squared, 4, minus 2, parentheses squared is 4. 8 minus 9 is minus 1. That's 1/10. Where else did I have 1/10? Had it right there. It's just 0.1. And 12 minus 9 is 3. That just 9 over 10, 0.9. Okay? Now I add all these up. So each one of these terms, 0 plus 1.6. I'm not going to put the 0. Time out. So I've got 1.6 plus 0.1 plus 0.4 plus 0.9 plus 0.4 plus 0.4 plus 0.1 plus 0.9. Let's add that up. Okay. 1.6 plus 0.1 plus 0.4 plus 0.9 plus 0.4 plus 0.4 plus 0.1 plus 0.9. 4.8. Now, all I've found here is the sum of squares right here. So I've got equals 4.8 divided by 10. That's going to give me my variance. So that's just going to move the decimal over. So I've got 0.48. So that's my variance, 0.48. Now I'm going to check this. So I just went through all the terms. There's a lot of room for error that I could have made as I went through each one of these pieces. So I'm going to check this with the calculator using these numbers. And so Let's get out of this screen, if it will let me. There we go. And let's scroll over to our calculator. And let's go to Stat, Enter, scroll up, Clear, Enter, scroll over, up, Clear, Enter. So I've got a clear screen. And put in my numbers for this one. 2, 3, 4, 5, 6, 7, 8. Okay, yeah. So I've got 9, Enter, 5, Enter, 9, Enter, 10, Enter, 11, Enter, 12, Enter, 7, Enter, 7, Enter, 8, Enter, 12, Enter, right? So 12, 8, 7, 7, 12, 11, 10, 9, 5, 9. Good. There we are. Now, of this set, I want to find the population variance. And I stated that it was, whoops, yeah, 0.48. So what I'm going to do now is I'm going to use the second function of the stat key to go to the list. But first I'm going to go second mode to quit, second list, scroll over to math, and scroll down to variance number 8. I'll hit enter. What's the variance? Well, that's interesting. So let me do it a different way. Stat, see if I get the same thing. Stat, calc, one variable, stats. Oops. Interesting. I'm going to have to walk back through my stuff here because I have made an error somewhere, or I made a flaw in the calculator. So let me go back to here. Let me bring this up. So I did the sum of squares. The mean was 9. So I did 9 minus 9, 0. 5 minus 9 minus 4 is 16. Yep, 16 divided by 10. I had that right, 1.6. Another 0. 10 minus 9 is, yep, 10 minus 9 is 1. 1 squared, 1. 10 is 0.1. 11 over 9, that's 4 over 10. And I did that right. It was 0.4. And then that was 11. 12 minus 9 is 3. That's 9/10. That's 0.9. 7 minus 9 is minus 2. 4/10 is 0.4. 7 minus 9 is minus 2. 0.4. 8 minus 9 is 1. That's minus 1. And then squared is 1. 1 over 10. And then 12 minus 9 is 3 again. So then I went 1.6, 1, wait, 1.6, 0.1, 0.4, 0.9, 0.4, 0.4, 0.1, 0.9. And I got 4.8. And when I divide it by 10, I get point. Right. When I put it up here, when I divided by 10, I got 0.48. So there's what I'm looking at. So nine, 5, 9, 10, 11, 12. Okay, I figured out my mistake. It took me just a second. Several things that are going on. Whew. So I had to take a step back and take a look at this. So I took every one of these terms and divided by 10. And so when I added all of this up, this is my variance right here. It's 4.8. So what I did accidentally here was I divided again by 10. Shouldn't have done that. I should have just left it right there. So that was just an oversight on my part. It took me a minute to find that. Now when I was doing it on the calculator, no problem here. There's your variance. So I did everything right. I thought I did because I walked through it pretty meticulously. But I divided by 10, then divided by 10 again. So let's go back to the calculator and I'll tell you what's happening here. What we found in this problem was population variance. Second, quit. Whoops. Okay, let's get back to stat, edit. In this problem, when I go to second, quit, second list over to math, and I scroll down to variance, I'm finding the sample variance, second L1, which is 5.3. So that is 48 divided by 9, which would be n minus 1. That's why we get the 5.3. So I was not drastically off, which I did not think I was, but I just could not figure out what I was doing. But I'm doing population variance in the video step by step. Did all of that right with the exception of the double divisor. And then in this one, when I found the variance, this is the sample variance, which is divided by n minus 1. What I was doing on step by step was the population variance. No problem. A very quick catch, and I hope I didn't cuss on there when I was going through this, but I may have. All right. So now let's look at a last example with different numbers, and I think this is my last one. Probably should be, considering it's been a long day. So the population standard deviation of a population data set of n entries. We've already looked at this, and here's the step-by-step that we do. Now, I did this already. I found the mean in the previous, then I found the deviations, then I squared them. And if you remember in the last video, I do that all in one step. Most people do. But those are the individual pieces. Then I take the sum of squares, the sum of those deviations squared, and then I put that in the numerator, and I divide by n just one time. And this gives me variance. And the mathematical relationship between variance and standard deviation is that the standard deviation is the square root of whatever you get for variance. So you just take that variance, whatever it is, take the square root of it, and that's the standard deviation. And that's it. So let me go through just a quick version of this one. And here we go. So I'm going to go sigma squared is equal to the summation of x minus mu squared divided by n. No problem. Oops, the square didn't go. There we go. So I'm going to go, and I'm not going to do every single piece here, but I'm just going to go right below. I'm going to go, first of all, I've got to find the mean. So 4 plus 15 plus 9 plus 12 plus 16 plus 8 plus 11 plus 19 plus 14 equals, divided by, it's like 9. So my mean is 12. So I'll write right up here that the mean is 12 just for reference. Okay, back to purple. So I'm going to have 4 subtract 12 squared divided by 9. Yep. Plus 15 minus 12 squared divided by 9 plus dot dot dot, plus the last one would be 14 subtract 12 squared divided by 9. Whatever I get there is going to be the variance. So let me work through this. See if I still have it on my calculator. I don't. Of course I don't. Let me put this in real quick. So I've got 4, 15, 9, 12, 16, 8, 11, 19, 14. Okay? I'm going to go right up here and I'm going to go second L1 minus 12 squared all the way down. Second quit, second stat over to sum. And I'm going to get the sum of L2, which is 168. So what I'm getting right here is at the top, numerator will be 168, and that's 168, I'm sorry, divided by 9. So I get that the variance is 18 point, I'll round it to 2 places, 67. Now if I took 168 divided by 8, that would be 21. Yeah. So my answer here at 18.67 is correct. That is the variance. Now in order to find, and all I did there, by the way, was I just used my calculator to run through the cells real quick to do what I did not outlay here because I don't have room on this slide. What I did on the previous slide, which was correct up until the end. The standard deviation, which is what we're looking for here, is going to be square root of whatever the variance is, which is going to be the square root of 18.67. 18.67, 4.32. 4.32. So squeeze in at the bottom. Handwriting gets worse as I get closer to the bottom, but I hope you can see that. So the standard deviation of this particular set is 4.32. The variance of this set is 18.67. Again, because we're dividing by this n right here, because we're dividing by n, because we're working with mu, these are associated with the population. Sigma, also a giveaway. Sigma squared, also lowercase sigma, representing both variance and standard deviation, are giveaways that we're working with the population. And so I use this form right here. Okay, I think that's it for this particular video. I'll upload this tonight, and I do apologize for what I missed on that previous problem. I did everything correct, but just like a regular student, if I've had a long day at work, I divided each one of them by 10, and then I divided again by 10 and moved the decimal one too many. When I did it on the calculator finds the sample variance, which is 5.3, whereas I had gotten, I think, 4.8. So that there's going to be just a slight difference because that denominator is n minus 1 as opposed to n. So anyway, hope this helps. Just a little quick video on some of the problems. I will put an announcement up tonight letting you know exactly which problems I want you to work on. If you have any questions, I will do some open office hours that I will announce. More than welcome to come on there. You parents, brothers, sisters, whoever, if you have any questions on this, I'll be glad to answer them. And I do it all on just on my YouTube channel. So, all right, that's all I've got. And thanks for being here. Thanks for being patient as I troubleshot my numbers in that previous problem.